Hello, my name is Karen, and I'm going to give you a quick guide to our unparametric nitrous oxide microsensors. This introduction will focus on the most important measuring characteristics of the nitrous oxide sensor. If you would like in-depth information and detail about nitrous oxide sensors, please see the lecture about Unisense unparametric microsensors. This is a couple of photos of Unisense nitrous oxide microsensors. We make them with different cables and connectors so they can be used in the lab and in the field. Our nitrous oxide sensor is also produced in a durable version for real-time nitrous oxide monitoring in wastewater treatment plant. This model is sold by our subsidiary company, Unisense Environment. The nitrous oxide sensor consists of a tapered glass casing with a silicone membrane, a working electrode, a reference electrode, and a guide electrode. The negatively polarized working electrode is made of indium, which has nitrous oxide reduction catalytic properties. The electrons are supplied by the reference electrode. The guide electrode protects the working electrode from reducible substances dissolved in the electrolyte, so the baseline is as small as possible. These electrodes are submerged in an organic electrolyte, which ensures electrical contact between the electrode as well as charge balance. The nitrous oxide microsensor is built into a second tapered glass casing with a silicone membrane. This is called the front guard. The front guard contains an oxygen scavenging solution consisting of alkaline sodium ascorbate, which is a strong antioxidant. This solution reduces oxygen, which would otherwise interfere with the nitrous oxide measurements because oxygen is readily reduced on the indium working electrode. The current that is generated is proportional to the partial pressure of nitrous oxide. The current is very small and will only guarantee the performance of the sensor when used with Unisense amplifiers. Detailed specifications are available on our website. I will, however, elaborate on a few of the most important sensor specifications. Unisense microsensors are handmade, and our skilled technicians can customize sensors to obtain the best possible characteristics and design to your specific application. The model name indicates the sensor type and tip size. Hence, a N₂O 50 is a nitrous oxide sensor with a 50 micrometer tip. We produce them with standard tip diameters from 50 to 500 micrometers, but can customize them with a tip size down to 30 micrometer. The N₂O is a robust, long-living version for online bulk water monitoring. Besides the tip size, we can also customize the design to be more or less slender, as well as the body length and shape. Please see our tip selection guide to get more information about choosing the right tip size for your application. The detection limit and sensitivity will be strongly influenced by the experimental design. But a standard nitrous oxide sensor has a detection limit of 0.1 micromolar. However, we can make the N₂O 500 and N₂O with a detection limit down to 25 nanomolar. Due to the rather complicated design of the nitrous oxide microsensor, the response time is relatively slow compared to other Unisense microsensors. The 90% response time is typically about 20 seconds for most models and up to 45 seconds for the N₂O. We can modify and adapt our nitrous oxide sensors, making them useful for a broad range of applications. We can build the sensors into needles to protect the glass sensor, and that also allows for piercing membranes of closed incubations. With a protection cap, the sensor can be safely used for bulk measurements in larger samples. For our microrespiration system, the sensor is equipped with a special guide and has a long, slender tip. which can be inserted into the small chambers without contaminating the small samples. The sensor body can also be made of steel with threads, which makes it possible to screw it into pipe systems or incubations. The sensors can also be mounted in different gas-tight flow cells. We have these glass flow cells, as well as pressure-tolerant swage-lock steel flow cells and peak flow cells. In general, if you have any special requests regarding adaptations, please do not hesitate to contact us. We would be happy to discuss your application and find the right solution. Thank you for watching this Unisens microsensor lecture. I hope you enjoyed it. If you have any questions, you are more than welcome to contact us at sales@unisens.com.